Hi, good afternoon, everyone. My name is Brian. I'm the solutions engineer with Keysight Technology, and I'm based in Singapore. A pleasure to be able to present a paper in this seminar over here. So the topic of this afternoon, on my part, will be testing conformance and interoperability of electric vehicle and charging infrastructure. Right, so that's the agenda that I have for my session. So I talk a little bit about the charging interface test challenges and then what Keysight Technologies is able to offer for the testing of the charging interface. And then, of course, I'll end off with a quick question and answers. So this slides over here shows the overall Keysight portfolio in the e-mobility solutions. So Keysight has test solutions for the charging technology, both at the infrastructure, meaning the charging station, as well as the electric vehicle itself. We also have test solutions for the electric inverter in the car, and also test solutions for the energy storages that goes from cell, modules, and pack. And we also have test solutions for battery management system. All right. So that is the overall test solutions that Keysight is capable of in terms of on the e-mobility space. And these are some example pictures of our customers' installations. So on the top left and on the bottom left, these are the test solutions for the charging interface, both for the infrastructure and the EV itself. So on the bottom left, that picture is the EMC compliance test for electric vehicle and charging stations. So electric vehicles and charging stations are required to meet the electromagnetic emissions as per other electronic product, like consumer product as well. And in the middle pictures, these are the installations for battery tests. And on the top right-hand corner, this is the test solutions for battery management system. And on the bottom right, this is the electric inverter test solutions. So my topic on testing of charging infrastructure is very close to this afternoon topic, which is on the energy. So as we understand that with the proliferations of electric vehicle, this has created a tremendous demand on the grid, because you can see if electric vehicles, the battery inside there are getting bigger and bigger for the fact that the car itself requires longer driving range, and with a bigger battery pack within the vehicle, then obviously the next question is, how long do I need to charge up the battery pack? And in order to speed up the charging process, obviously, you require a lot of energy during the charging process. And with that kind of also reshape how the grid infrastructure is looking at right now. As Morocco has presented, there's a very different way of generating power, either from DER, distributed energy resource, which is equivalent to the variable energy resource. All right, and EV now is also considered as an energy resource because of the fact that it has a big battery pack in there, and the charging technology has advanced the point where it could return the power back to the grid from the electric vehicle itself. So this slide just goes to show that the EVs are creating more demand on the grid, all right? And as a result of that, new ways of generating energy is required, and there will be more and more investment into grid-tied battery storage, all right? And more investments will be needed in renewables in order to cope with the demand created by the EVs. And it is also expected that there will be 20 million charging stations worldwide by 2025. And with that, the charging technology is also ever increasing to go towards faster charging. Like, for example, the CCS, the combined charging standard, we are looking at potentially 450 kilowatts of charging power. The GPT technology, which is the Chinese charging standard, they are looking at 900 kilowatts of charging power. And for the heavy-duty EVs, this refers to, for example, trucks. And in the mining industry, where the big mining vehicles, they are also undergoing a transformation of electrification. And these vehicles will potentially require at least 1.5 megawatts in charging power. All right. So what is really important is that, if possible, we are trying to harmonize all the different charging standards, and this makes testing much easier. However, different region and different economical and political interests will generally prevent the harmonizations of one single standard worldwide. So what we are seeing is that there are many different charging standards in the world. Now, before I go into that, so let's just look at the few charging modes that are available today. The first mode of charging, obviously, is AC charging, where you plug the electric vehicle directly to the grid. This is now considered as obsolete because of the fact that there are many various hazardous conditions that can happen if we were to plug the EV directly to the grid itself. And then the second type will be what we call AC home standard charging, where you buy an electric vehicle and the electric vehicle comes with this what we call a charging adapter, where they can plug in safely because it has a little control unit that provides some electrical safety protection during charging. And then there's the public charging, either the AC public charging or the DC public charging, all right? Now, for AC charging, the standards being used today are the IEC 61851 specification, all right? And this has been adopted for the standard charging for AC, all right? It's low cost and very easily available, and the technology involved for AC charging is also relatively simple. All right, there's no high-level communication. However, the charging power is typically low, maybe up to 20 kilowatts as the max, because the amount of current that can be pulled typically from a single phase is perhaps just 32 amps. And one of the big challenges that with AC charging is that with different regions, you get different line voltages, so that makes the implementation difficult. The second mode of charging is DC charging, all right? And even for DC charging, there are multiple standards available. And because of the fact that DC charging utilizes extremely high current, so some kind of high-level communication is necessary to ensure that both the charging stations and EVs are able to communicate and ensure that the connection is safe before energy transfer. All right, and typically for DC charging, I think today, maybe not so much in Philippines. Today I've been here in Philippines since Monday. I've been in Cebu and then back here, but I don't see a lot of charging station. But if you within Southeast Asia, for example, in Thailand or in Vietnam or even in Singapore, you'll find that there has been a lot of high-power DC charging. I think the common ones are 120 kilowatts. I think I've seen some that are as big as 360 kilowatts. And these will require a lot of power. And these are the DC chargers that will be up and coming because of the fact that we do not want to be sitting down there waiting for the car to be charged up. We want our EVs to be the same as an internal combustion engine, where you go in there, you put in your fuel within less than a minute, and then you're ready to go. So if you look at the world, you'll find that there are many different standards being utilized. For example, in North America, where Tesla is dominant, they have their own standards. But however, for DC charging, it is typically the CCS Type 1 or the CCS Type 2. This is found in North America, in Europe. And then in Japan, we have the CHAdeMO standard. And then for the Chinese, they have the GPT standards. And then now, in addition to that, we also have a CHAoji standard. This is a combination of the Japanese standard and the Chinese standard to allow higher power of charging. All right. And then finally, just recently, we also seen the release of the North America charging standard, which is basically Tesla opening up the charging interface testing standard for the rest of the world to use. Oops, sorry. So one of the things about e-mobility is that it is really important to have your vehicle and charging station being able to interoperate together, because one of the things that we don't want is that your battery of your electric vehicle is low and then you drive your car up to the charging station, and when you're plugging in the charger, you just simply refuse to charge. So this is why testing of the charging station and the electric vehicle is really important to ensure that it's able to interoperate. Only then would e-mobility be able to scale, and we'll see higher adoption of electric vehicle and electrifying of the transportation in order to hit the net zero emission goal that is pledged by governments around the world. So in the past, the testing is very simple because of the fact that there's only a few models of electric vehicle and charging stations. So what manufacturer would do is they would simply go out there and buy all the charging stations, and then they will cross-test against one another. But today, we have so many different brands, and even a particular brand, they have so many different models of charging station in electric vehicles, so it's no longer possible to do this kind of testing, all right? So what is really needed, and also in the name of good science, is to have a universal test device where all the electric vehicle and charging stations are being tested using this universal test device, all right? Only then when you have any problems or any issues during the testing, then you know that this is a problem with the, either the electric vehicle or the charging station only, okay? And for robustness in the test, you only want to ensure that you'll be able to test the communication as well as to the power level, all right? So this will ensure that your test is sufficient to ensure that the devices, the EVs and the charging station will be able to interoperate against one another. And if you look at the various specifications available today, all right, starting from 2014 when the early specifications of the IEC standard is available, all right? So what I'm trying to say here is that even if you design the electric vehicle or charging station according to the standard, it does not guarantee interoperability. It just simply means that your system design follows a baseline design, all right? However, to be able to interoperate, you need to ensure that the electric vehicle and charging station are tested based on a set of rules, and this is where the test specification is something that you want to look at. So here you can see that the specification only defines the system topology and the safety requirement for EVs and charging station, whereas for the communication itself, it is necessary to check on the adherence of the communication to the standard. This will then ensure that when the device, when the charging stations and the electric vehicle gets together, they are able to talk in a common language, and a common language that both the charging station and the EVs are able to understand. And there's no breakdown in the communication which will interrupt the charging process. Now, Keysight is a core member of Charin. Charin EV is actually the organization that is responsible for the CCS standard. The CCS stands for Combined Charging Standards, which is the charging interface for DC Type 1 and DC Type 2, all right? And Keysight is a core member of Charin organization. Being a core member, Keysight has the responsibility to define test methodology in the goal of achieving interoperability. So once this test methodology gets accepted by the organization, then this becomes the test specifications being published by Charin EV. And this slide here just to show an overall portfolio of the available tools from Keysight for testing the charging interface. And these tools will map into various development stage, all the way from R&D to production to maintenance. So on the left, we have our charging communication interface tester. So this little box on the left is meant for EV and EVSE manufacturers when they are designing their charging circuit, where they are only interested in the charging communication without energy transfer. And if you need to test up to energy transfer, then we have our charging discovery software and charging discovery system portfolio, which is in the middle. All right, so you see there are three different systems. One is the little silver stainless steel, and then a middle box, and then two big boxes at the back. So these are our charging discovery system that can be used to test the EV and the charging station. And then at the bottom, these are Keysight power system that will emulate the power sources or the power sink during testing, depending on whether you're testing the charging station or EV. And then lastly, on the right, we have a protocol tracer, This is a box that can actually listen to the communication between a car and a charging station, so that then you would try to understand the communication breakdown to find charging interruption problems. All right. So these are the three main versions of the charging discovery system: the SL1040A portable series, the SL1047A high power series, and then the EMC series as well. All right, and the three different use cases for the charging discoverer system, the CDS in short. Here we are trying to test the EV. So we have the charging discovery system performing the role of a charging station, and then from there you can test out the various charging networks as well as the circuitry, or also to test for conformance and interoperability of the electric vehicle. And then the next use case would be when you're testing the charging station. Again, similarly, here you are trying to test the charging circuit as well as functional tests, conformance or interoperability, or end-of-line testing. And then the last use case would be to check for charging interruptions or analysis of interoperability issue, where you have the charging discovery system in the middle between the charging station and the vehicle itself. And this is a test environment for electromagnetic compatibility. So I've taken this diagram from the IEC 61851 on the EMC test setup requirement. So Keysight actually released a different version of the charging discovery system so that it can be used in the anechoic chamber during EMC tests, because if you look at the IEC 61851 EMC test setup, this requires the EV simulating equipment to be in the same anechoic environment as the device under test, right? And this is the software that will be used to control the equipment, right? So it's an all-in-one software where it allows you to control the system, either to perform EV or EVSE emulation, or you could also look at the data that has been collected during tests. You can look at the communication, as well as it allows you to develop different test scenarios. And for conformance testing, we are using the Spirent TTCN3 workbench. So Spirent is a company that is very well known to supply the TTCN3 workbench. It is kind of the standards for conformance testing. So Keysight is using this TTCN3 framework to offer conformance test library. So this test library could be used for the DIN standard, the 70121, or the ISO standard, the ISO 15118. Okay. And during the test, if you require energy transfer, then Keysight has various power systems to work together with the charging discovery system. This could be the high power series, where we offer up to 300 kilowatts, plus minus 600 amps, up to 1500 volts DC. Or we have some mid-power series and low-power series, so it really depends on what is the power level that you want to test, and Keysight has a appropriate, what we call power emulators for the power source and sink. We also have AC power system, where these serve as a dual role. It can serve as a grid emulator if necessary, all right? Or it could also be used as a AC load as well if you're testing for AC charging system. So Keysight has been supplying our test solutions to more than 100 customers across the world. All right, they could be car manufacturers, they could be charging station manufacturers, also test facility as well. So Keysight has been very successful in providing test solutions for these groups of people across the world. And that's the end of my presentation. Any questions? If not, thank you for your time and have a good rest of the day. Thank you.
Thank you, Mr. Brian Yeo, for your presentation. So now I would like to, final question, are there any other questions from the audience? None, okay. I would like to give this certificate of appreciation to Mr. Brian Yeo for sharing their invaluable insight and work on testing conformance and interoperability of EVs and charging infrastructure during the NISCON 2024 conference. Given this day, July 2024, signed by Dr. Lu Andrew Tria.